Hello students, welcome to Physics Book A. In this video, we shall discuss wave equation of a stretched string. Wave equation of a stretched string. तो एक स्ट्रेच्ड स्ट्रिंग के लिए हम वेव इक्वेशन डेवलप करेंगे। तो शुरू करते हैं। पहले एक स्ट्रिंग लेते हैं, इलास्टिक स्ट्रिंग। That means it has the ability to regain its original position after stretching. If we keep the force away, applied force away, then it can regain its original position. So it is an elastic string. Suppose its mass per unit length is small m, mass per unit length, it is stretched, and while stretching a tension T acts upon it. When we stretch, a tension T acts upon it, and after stretching it, it is fixed at two ends. One of the end is considered to be at the origin and another end is suppose named as A, and the equilibrium position of the string, that means when it is rest, when it is not vibrating, when it is not deflected from its original position, that equilibrium position coincides with the x-axis, and the straight line passing through origin and perpendicular to the x-axis is considered to be the y-axis. So these things are given to us. Now, before deriving the wave equation, let us make certain assumptions. Some major assumptions are: the string OA, it is confined to vibrate in XY plane only. Vibrate in XY plane. That means it is restricted to, it is limited to vibrate in XY plane. Matlab like this. And the particles which are lying on the string, they vibrate in the XY plane, they move in the XY plane perpendicular to the x-axis. Then second assumption, when we stretch the string, before fixing them at the end points, the tension which acts upon it, that we have considered it to be T, that tension remains constant at all times and at all positions. T is constant. Properly understand that this tension is the tension which acts upon the string when we stretch it before fixing at the end points. Then third assumption, ये जो स्ट्रिंग का वेट है, weight of the string is negligible as compared to this tension. Weight of the string is very small as compared to the tension. That means gravitational force acting upon the string is neglected. Then fourth assumption, the frictional force is negligible. The force of friction, the friction is negligible. That means the medium in which the string vibrates is it may undergo friction with the surrounding medium particles of the medium, and that friction is negligible. Friction is very small. One more thing, the slope, when it is deflected from the original position, it is displaced from the original position to make it vibrate. At each point of the deflected position, the slope of the displacement curve is very small. Slope is very small. Displacement curve का slope बहुत छोटा है. So assuming these things, let us derive the wave equation. Suppose at a particular instant the displacement curve is like this. Let me consider 2 points P and Q on the displacement curve, which are very close to each other. At point P, it is T1. At point Q, the tension is suppose T2, and it makes an angle beta with the x-axis. That means it is T1 with x-axis, it is alpha. It is T2, makes an angle beta with the x-axis. Then resolving T1 and T2 and finding out their x component and y component, we have this as T1 sin alpha, this as T2 sin beta. This is T1, this is alpha, so this is T1 cos alpha, and this is T2, this angle is beta, so T2 cos beta. So which is along the x component is T2 cos beta, and that along the y component is T2 sin beta. This is T1 cos alpha, T1 sin alpha, and we have the displacement of a particle from its original position is function of x and t, where x is the position of the particle and t is the time at which it is displaced. So it is function of x and t. Now you see, students, this T1 cos alpha and T2 cos beta, they are in opposite direction. These two are also in opposite direction. But come back to our assumption. Here the particles are being displaced only along the y-axis. There is no displacement of the particles along the x-axis. That means there is no vibration along the x-axis. Vibration is confined to the xy plane, and the particles are displaced along the y-axis. Therefore, the T1 cos alpha and T2 cos of beta, they cancel each other. That means T1 cos alpha is equal to T2 cos beta. Both of them are along x-axis, right? Now again we have the tension which acts on the string before fixing at the endpoints is T, and it remains constant throughout the time and position. Therefore, since it remains constant at all times, so these two must be equal to T. T1 cos alpha is equal to T, T2 cos beta is equal to T. Let it be equation 1. Now come again to these two figures. So here it is T2 sin beta and here it is T1 sin alpha. Now the net force acting on the string, net force acting on the string will be T2 sin beta minus T1 sin alpha, because it is going upward. Therefore T2 sin beta minus T1 sin alpha. But according to Newton's second law of motion, this net force is equal to mass into acceleration. So this net force is equal to mass into acceleration. तो मास कितना होगा? ये जो पोर्शन है इसका मास हमको जानना है. वन मोर थिंग, सी ये जो पोजीशन है Q, सपोज फ्रॉम द ओरिजिन, पहले P का पोजीशन लेता हूँ. ये जो P का पोजीशन है ओरिजिन से, सपोज इसका डिस्टेंस x है, मतलब ये कोऑर्डिनेट x0, और ये जो Q का पोजीशन है सपोज ये है x प्लस डेल्टा x, मतलब ये दोनों के बीच में डिस्टेंस डेल्टा x. तो ये इतने पोर्शन, ये जो स्ट्रिंग है, स्ट्रिंग का इतने, ये जो पोर्शन जिसका लेंथ डेल्टा x है उसका मास कितना है? वी हैव टेकन मास पर यूनिट लेंथ इज m. तो ये जो डेल्टा x लेंथ का स्ट्रिंग है उसका मास कितना होगा? m इंटू डेल्टा x. सो दिस मास, दैट मीन्स m इंटू डेल्टा x, और एक्सेलरेशन क्या होगा? सेकेंड डेरिवेटिव ऑफ डिस्प्लेसमेंट विथ रेस्पेक्ट टू टाइम. सो डेल स्क्वायर y बाय डेल t स्क्वायर. So this net force is equal to this. That means T2 sin beta minus T1 sin alpha is equal to m into delta x into del square y by del t square. Suppose this is equation number 2. Both sides of equation 2 by t, T2 sin beta divided by t minus T1 sin alpha divided by t is equal to m into delta x by t into del square y by del t square. Now look at equation 1. In place of t, I can write T2 cos beta, and in place of this t, I can write T1 cos alpha. So T2 sin beta by T2 cos beta minus T1 sin alpha by T1 cos alpha is equal to m into delta x by t del square y by del t square. T1 goes out, T2 cancel out, sin beta by cos beta, tan beta minus tan alpha is equal to m into delta x by t del square y by del t square. Now divide both sides by m delta x by t. Then I will obtain t by m into tan beta minus tan alpha divided by delta x is equal to del square y by del t square. It be equation number 3. Again students, we know that suppose a line is making certain angle theta with the x-axis, then its slope is given by tan theta. Suppose this is delta y and this is delta x, so tan theta is equal to delta y by delta x. If delta y and delta x are very small, if we take limit delta x tends to 0, then it becomes dy by dx. So using this formula here, we can obtain t by m into tan beta. Tan beta is the slope at point q. So del y by del x at point q minus del y by del x at point p divided by delta x is equal to del square y by del t square. I wrote it left side. इसको ऐसे भी लिख सकते हैं t by m del y by del x at position x plus delta x minus del y by del x at position x divided by del x. This is equal to del square y by del t square. If delta x tends to 0, then our q approaches p. If delta x tends to 0, then q will approach p. Under this limiting condition, we can write del square y by del t square is equal to t by m. Look at this expression. If we take limit delta x tends to 0, del y by del x, x plus del x at the position this, minus del y by del x at position x divided by del x. This is nothing but del square y by del x square, second derivative. So this is del square y by del x square. और इसको ऐसे भी लिख सकते हैं del square y by del t square is equal to c square del square y by del x square. This is the wave equation of the stretched string, and where c square is equal to t by m or c is equal to square root of t by m. This is the partial differential equation of second order and it represents the wave equation of the stretched string. ये वीडियो में इतना ही. नेक्स्ट वीडियो में हम ये जो इक्वेशन मिला इसका सल्यूशन निकालेंगे, डिफरेंट बाउंड्री कंडीशंस लेके इसका सल्यूशंस निकालेंगे. हैव ए गुड डे.